Okay, so let's look at the solutions to those examples. Now, I mentioned we'd be using the method of substitution, so let's recall what we have. We have, for absolute value of x less than 1, that this series, x to the n, is equal to 1 over 1 minus x. Now, we didn't have to use x. X is just some letter that we decided to use. We could have easily used, let's say, w. And we would add 1 over 1 minus w equals the sum of w to the n. W could be as mad as you want. This formula is still valid as long as it's of size less than 1. So let's solve the first problem. h of x is equal to 1 over 1 plus x. I can rewrite this as 1 over 1 minus x. Now, this is the sum, minus x to the n. N goes from 0 to infinity. When is this formula valid? Well, the thing I want to plug in is minus x, so I need that minus x has size less than 1. Otherwise, this equality makes no sense at all. This is equal to, take out the minus 1, write minus x as minus 1 times x, and we get this. And clearly here, our CNs are minus 1 to the n. Now, minus x, absolute value of it less than 1, is the same as absolute value of x less than 1, because absolute value doesn't care about sign. Okay, move on to the second example. J of x is equal to 1 plus x to the 7 under 1 is equal to, again, the same trick. We write x to the 7 as minus x to the 7. And this is sum is 0 to infinity minus x to the 7 to the n, which is, separate them out again, minus 1 to the n, x to the 7n. It goes from 0 to infinity. Now this is 1 minus x to the 7 plus x to the 14. This is not the same as the other power series we looked at. It's not x to the n, it's x to the 7n, so we have to be a little bit more careful. Now, C0 is 1. C1, well, there is no x term, so C1 is 0. C2 is 0. There is no square term. All the way up until we get to C7, and we saw that it's minus 1. C8 was 0, there's no x to the 8th term. And so on up to C14 is 1. C15 is 0, and it goes on like this. So it's a much more complicated collection of CNs than the first example. Now, when is this equality valid? I can't always write this. This is valid for, well, what's the thing I'm plugging in? Minus x to the 7. Its absolute value less than 1. That's the same as absolute value of x to the 7 less than 1. Which of course is the same as absolute value of x less than 1. So we found a power series representation for h and for j, and we found where they're valid. And we've identified the CNs.